Electrolysis is a method used to split apart ionic compounds into their elements using electricity. Electro means electricity. Lysis means to split up.
The ionic compound is either melted or dissolved to form a solution, depending on the compound. This forms a liquid in which the ions are free to move. This is the electrolyte. Electrodes are added, which are connected to a power supply. This forms a complete circuit so current can flow. The positive electrode is called the anode, and the negative electrode is called the cathode.
You can investigate the products made from the electrolysis of copper sulfate solution using both inert and copper electrodes. Inert electrodes are ones that do not react in the electrolysis process. They are usually made from a form of carbon called graphite. Let's start by using inert electrodes.
The first step is to put on eye protection and pour some copper sulfate solution into a beaker. This is copper sulfate dissolved in water, and so it will contain copper ions and sulfate ions from the copper sulfate, as well as hydrogen ions and hydroxide ions from the water.
Next, the electrodes are placed into the solution. It's important that the electrodes do not touch, as this will cause a short circuit, and electrolysis will not take place. A good way of making sure this does not happen is to place a lid with 2 holes in it on top of the beaker, and then put the electrodes through the holes.
The electrodes need to be connected up to the power supply. The power supply used should be a low-voltage power pack which is plugged into the mains. Leads with crocodile clips at one end are used. The leads are clipped onto the electrodes and then plugged into the DC or direct current terminals of the power pack. These are red and black. The red terminal is positive and the black is negative.
At this point, it's a good idea to make a prediction where you state what products will be formed at each electrode. Copper sulfate solution contains positively charged copper ions and hydrogen ions and negatively charged sulfate ions and hydroxide ions. If the metal ion is less reactive than hydrogen, the metal will be discharged at the cathode. Otherwise, hydrogen ions will be discharged. If a halogen ion such as chloride is present, then it will be discharged at the anode. Otherwise, hydroxide ions will be discharged to form oxygen gas. Sulfate ions are never discharged. Can you predict what products will be formed from the electrolysis of copper sulfate?
When you are ready to test your prediction, 5 volts is selected on the power pack and then it is switched on. You need to observe the electrodes carefully in order to work out what product is forming at each electrode. Are either of the electrodes changing color? This could indicate that a metal is forming on the electrode. Are there bubbles of gas forming?
For copper sulfate solution, you will observe that the cathode goes a brown color. This is because copper has been deposited on it. Positive copper ions are gaining electrons to form copper atoms. For higher tier students, the half equation at the cathode is shown on the screen as
Copper 2 plus aqueous plus 2 electrons forms copper solid. Reduction. Bubbles of oxygen gas are formed at the anode. Negative hydroxide ions are losing electrons to form oxygen molecules and water. The half equation at the anode is shown on the screen as 4OH- aqueous gives 4 electrons plus oxygen gas plus 2H2O liquid. Oxidation.
You will also see that the blue colour of the copper sulfate solution fades as the copper ions are removed from the solution. Next, you can investigate the electrolysis of copper sulfate using copper electrodes.
This time, before you start, measure the mass of both the anode and the cathode. Run the electrolysis as before for 5 minutes. Then turn off the power supply, dry the electrodes, and record their final mass. You will see that the anode has lost mass and the cathode has gained mass. This happens because at the anode, copper atoms in the electrode are losing electrons to form copper ions. These go into solution. This time, the half equation at the anode is shown on screen as copper solid gives 2 electrons and copper 2 plus aqueous. Oxidation.
Positively charged copper ions are attracted to the cathode, where they gain electrons to form copper atoms, which are deposited on the cathode.
Finally, the half equation at the cathode is shown as copper 2 plus aqueous plus 2 electrons gives copper solid, reduction. The current flowing and the time the electrolysis is carried out for will affect the change in mass of the electrodes. You can carry out an investigation based on this.
To vary the current, you will need to use a variable resistor in the circuit. This will allow you to change the resistance, and therefore the current in the circuit. Adding an ammeter as well will mean you can measure the current. If you plot the results on a line graph, the line shows that the change in mass is directly proportional to the current.